All right, what's up, everybody? Last video. I'll be back Monday. We have a test on Tuesday. And before we get to the new stuff, we got to do what we're supposed to do. Check this out. Many of us are setting ourselves up to struggle on our test Tuesday. I know a lot of us also have a probability test to retake. Sorry, I was out all week. I'll get you those back on Monday. You're going to have to do some prep over Thanksgiving and think about retakes, I think. We'll worry about that when I get back. Let's focus on this current unit, Test Tuesday. Many of you are making terrible decisions. With Lincoln, who's sitting behind me, we talk about red and green choices in kindergarten. You're making a lot of red choices. Don't complain to me. There he is, creeping around. Say hi, Lincoln. Tell him to make a green choice. Say, do your work, yo.
Make a green choice.
So, check it out. Here's why I'm saying what I'm saying. These are our assignments from some of our assignments from this week. Here's our first one. This is our Delta Math margin of error. I hope that you notice the same thing that I notice. I notice a few people who are making the right decisions and trying to put themselves in a position to succeed on their test, which is 70% of your grade. These are also all going in the grade book as zeros. So that is not even remotely close to good enough. So I don't want to hear anything about this is too hard or it was hard because you weren't here. You're straight up not doing it. That's the problem. It's not because I'm not there. It's not because it's too hard. Try harder or try in the first place. That's one. Here's another assignment. This is from a couple days ago, the Google form. I have 20 responses. There are 27 people just in period D. There are 18 people in period B. Those don't add up to 20. That means I have more than half of us, 25 of us, who have chosen to do nothing. That's 25 zeros in the grade book. More importantly, or equally importantly, that's 25 people who are going to have no clue how to do this kind of practice on the test. And then here's another Google form. Now, this one's for today's. So some of you haven't seen this yet, but you're also submitting this multiple times. So I'm sorry, for yesterday's when you're watching this video. So do what you got to do. Read the feedback. When you finish this Google form, look back at the results, right? You got to read all those comments. You have to work to build your own learning. Otherwise, you're just going to be feeding me a bunch of excuses about how you didn't do well on your test Tuesday. There's no excuse. This is the reason. I'm showing it to you right now. The good news is you have some time to rectify that. But after Tuesday, I'm not taking any of this. I take that back. Yeah, after Tuesday seems fair because that's the test and the point is to practice for the test. But after Tuesday, these are permanent zeros because if you didn't do anything, that's telling me you wasted a whole week of class. And that is completely unacceptable, right? I wouldn't let you do that if I were in the room. You shouldn't be doing that when I'm not there. So I'm sorry to start out with some negatives, but that's just absolutely ridiculous. Like you guys, some of us, I should say, you got to start acting like you're in high school and you care about your grades. No one's doing this for you. Put yourself in a position to succeed. And I'm laying into you now like I do all the time because I expect more. I know you can do better. My job is to push you to do better. Do better. Do something to start. So here we go. Let's get into the new stuff. Let's switch it up. Let's kind of shake out the negative. Let's think about what we have to do. Although I'm probably, quite honestly, the people who I'm trying to send that message to aren't even watching this video. But if you are, be a good friend. Be a leader. Tell your neighbor over there who's not doing what they're supposed to do to get to work. Be like, yo, man, we got a test Tuesday. Come on, let's do this together, right? Don't be mean about it. Don't be rude. Be positive. But let's support each other and do the right stuff. So here we go. Yesterday, we talked about drawing conclusions from a sample using margin of error. That was a little bit mathy. Today, we want to talk a little bit more about some of the conclusions we can draw through these 10 slides. And we want to talk about the idea of correlation versus causation. It is arguable that this is the most important thing you could learn in all of the statistics unit, because many times in real life, we see studies that suggest that a correlation means one thing causes the other. And that's what we want to dive into today. So check it out. Pause the video, read this. This is a sample question. After this video, you're going to have a Google form to do. Test Tuesday, you're going to see questions like this. This is the type of thing that we are going to see on the SATs or on our test. So pause it, read it, and think about it. And so now that you've read, right, our job is to try to decide, based on this context, do we think that these audio lessons caused people to do better in their course? For us to describe or to answer that, we have to understand the difference between correlation and causation and how we establish those relationships. So here's the deal. Grab your notebook. If you haven't, pause the video, take out your notes, and write this down. Correlation does not mean causation. I'll put myself right here. Correlation is simply a relationship between two variables, right? Another word for correlation would be relationship or association. If we're using an observational study or a survey, we cannot establish cause and effect. We can only see a relationship between two variables. And on the next couple slides, we'll talk a little bit about why. Causation is the idea that one variable in particular causes another, right? What it sounds like, right? One variable causes another. And the key thing, the key to all of these multiple choice questions is what we're seeing here and here. We can only establish cause and effect if we have an experiment. And the key distinguishing characteristic of an experiment is we see random assignment of treatments. So when we jump back to this slide, for us to decide if audio lessons cause improvement, we need to think about, was this an experiment? Or in other words, were people randomly assigned to these audio lessons or not? That's all we have to consider. So these are not really mathematical questions. These are more based on understanding how the data was collected. Right, so this screen, super important notes. Correlation does not mean causation. We see this all the time in real life. People incorrectly deciding that a relationship between two things means one causes another. So, by the way, here was the scariest pumpkin I saw on Halloween. It's a pretty good one. So, here's an example. If we looked at a scatter plot, I'm going to try to use my tablet here, but still experiencing technical difficulties, between people like ice cream sales and like the number of cases of sunburn, right? Looking at these two variables here, we would see a very strong positive association. When there's more ice cream sales, people get sunburned more often. But that is not causation, right? That's just a relationship, right? The relationship is caused by an extraneous variable. So what we would say is there's a lurking variable here. There's some other variable, which is dry, hot, and sunny summer weather, that makes it seem like when more ice cream is sold, people get sunburned more. So no, ice cream sales don't cause sunburn. If you go eat ice cream, that's not going to cause you to get sunburn, right? That should seem ridiculous. But there is this relationship because we have this lurking variable, right? Summer. When it's summer, ice cream sales go up. And when it's summer, cases of sunburn go up. And this is why we cannot establish cause and effect if we have a survey or observational study, because we might always have this lurking variable, summer, creeping around in the background. In an experiment, I can eliminate that lurking variable. I can make sure that I'm, assigning people ice cream and see if they're getting sunburn and make sure it's all at the same time of year. Another example. Let's say we want to look at, that's not that good one. I'll skip that. You can soak that in. By the way, all I did was type correlation versus causation in Google, click images, and look at stuff. So if you're a visual learner like me, that's a great strategy you might use. You can type in margin of error, click images, and you'll see a bunch of visual representations of that. Stratified sample, click images. So if you like visuals, that's a great resource or a great way to try to help build your understanding. That's super, super simple. I'll give you one more. If we look at the relationship between the number of firefighters who show up to a fire and the amount of damage that's done, which we usually measure monetarily in money by a fire, we also see a positive relationship, which suggests that the more firefighters that come to put out the fire, the more damage is caused. But again, this is just a correlation. This does not mean that firefighters are causing damage. This does not mean you're not like, if your house catches on fire, you're not going to call the fire department like, yo, hey, my house is on fire, but can you guys only send one firefighter? Because if you send a lot more, there's going to be a bunch of damage at my house, right? Like, no, you don't want to do that, right? We want a lot of firefighters to put out the fire. And the reason is there's another lurking variable here. There's some variable that's related to the number of firefighters. It's also related to the amount of damage, and it makes it seem like more firefighters cause damage. Sorry, more firefighters cause more damage. And I challenge you to pause the video and think about that right now. What variable might be related to number of firefighters who show up and the amount of damage makes it seem like more firefighters cause more damage? Pause. And now that you've unpaused, maybe you're thinking about something like, whoa, what just happened there? You're thinking about something like the size of the fire. Bigger fire means more firefighters. Bigger fire means more damage. So over here, there was a bunch of firefighters kicking down doors and chopping them down with axes and stuff, and they cause more damage. No, firefighters do not cause more damage. This is, we needed a lot of firefighters, and there was a lot of damage because there was a really gigantic fire. Here, we didn't need any firefighters. We didn't need as many. There wasn't as much damage because it was a small fire. And so that's why with observational studies and surveys, we cannot establish cause and effect. We need an experiment to eliminate this potential lurking variable. So back to this question, the one we started with. Pause the video and see what you think. At no point here did we randomly assign people to take audio lessons. And as a result, since we did not randomly assign anyone to take these audio lessons, this is not an experiment. People just chose to do this or not. So because this is not an experiment, that eliminates everything that tells us one thing causes another. Maybe the people who chose to take audio lessons just really like trying to learn a language. Maybe they studied more. Maybe they did more practice. So maybe it wasn't really the audio lessons that caused the improvement. Maybe it was just the type of person who chooses audio lessons is also the type of person who tries really hard to learn this foreign language. So because it's not an experiment, we can't use anything that says audio lessons cause improvement, no matter what the population is. No conclusion about cause and effect can be made, all because this is not an experiment. And I've kind of referenced this, but you could also pause here and kind of challenge yourself to think, how would I change this context? What would have to happen in this original context for the answer to be C? Now, one thing to notice here that's embedded is we have to consider, is it an experiment? Then yes, cause and effect. Not an experiment, no cause and effect. But we also have to think about the population that we're referencing, because we're only talking about students at this community center. We're not going to talk about any student who takes a foreign language course. We're not going to talk about any student who takes Spanish, right? We're going to talk about students at the community center who took Spanish, because we only are at a community center talking about Spanish, right? So we're not thinking about any other foreign language, and we're not talking about any student outside the community center. So that's why the answer would potentially be C. And hopefully you've realized that in order for the answer to be C, we would have to have random assignment. We would have to randomly assign some students to take audio lessons, and we would have to randomly assign some students to not take audio lessons in order for us to choose this option C as correct. All right, so to wrap it up, a couple things. You can just soak that fantastic cartoon in. I'm going to share a link that shows a bunch of different just kind of funny correlation causation graphs. Check that out just for fun. Stuff like this. Think about it. So to wrap up, before you hop into your Google form exit slip, here's what you got to remember. I would write this down. Again, you're kind of writing some of the same stuff twice, but there's plenty of evidence that shows us there's a strong correlation between how frequently you write something down and how much you retain it. And we got a test Tuesday. So correlation, what to know versus cause, what to know. Correlation does not mean one causes the other, right? We said that. Correlation, not causation. That's just a different way to say number one. And then the key thing is we can only establish cause and effect with an experiment, which means treatments have to be randomly assigned. So if there's no mention of random assignment of treatments, not an experiment, no cause and effect. That's it for today. Video wise, hop on that Google form and then use the rest of the time. Do what you got to do. Make green choices. For real.